The resting potential of a cell membrane is composed of sodium concentrated on the outside of the cell with a positive polarity, potassium concentrated on the inside of the cell with a negative polarity, negative 70 millivolts, and the membrane channels are closed, but K+ is able to escape through leaky ion channels.
Woohoo!
At the beginning of an action potential,
Boop-a-doop-boop-boop.
an electrical signal, also known as a receptor potential, is received by the dendrites,
Woohoo!
and then travels to the soma or cell body, and then towards the axon.
Yay!
When it arrives at the axon hillock, if the threshold of negative 55 millivolts is reached, the action potential will start. If threshold is not reached, no reaction will occur.
Oh no!
This is known as all or none. Then, the voltage-gated sodium channels open. The cell depolarizes from a sodium influx.
Woo!
It becomes 500 times more concentrated inside the cell than usual. At the peak, an action potential is created.
Woohoo!
Then, the sodium channels close and the voltage-gated potassium channels open. The cell repolarizes from a K efflux. The potassium channels close, but slowly, and then the cell hyperpolarizes below negative 70 millivolts.
Boom, 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 boom.
There are two types of refractory periods: absolute refractory periods and relative refractory periods. During an absolute refractory period, the sodium channels are inactive and an action potential could not be created again, no matter what. During a relative refractory period, the action potential could be created again, but the stimulus must be stronger than a normal stimulus would have to be to reach threshold. The cell depolarizes back to its resting membrane potential, and created action potential propagates to the next neuron membrane, and the same process occurs over and over. It creates a wave-like motion. Propagation is defined as the action potential generated at the axon hillock propagates as a wave along the axon. The currents flowing inwards at a point on the axon during an action potential spread out along the axon and depolarize the adjacent sections of its membrane. Initiation is defined as an action potential occurs when a neuron sends information down an axon, away from the cell body. Neuroscientists use other words, such as a spike or an impulse, for the action potential. Action potentials are caused when different ions cross the neuron membrane. The initiation of the action potential occurs at the axon hillock. Some axons are surrounded by a myelin sheath. Myelin is created by glial cells, oligodendrocytes in the central nervous system, and Schwann cells in the peripheral nervous system.
Schwann.
Action potentials travel over myelin and reoccur at the nodes of Ranvier. This is called saltatory conduction.
Woohoo!
Once it reaches the axon terminal, it releases calcium 2+. To move the neurotransmitters on the axon terminal to cause a signal or response in the body. When axons are not myelinated, the action potential must go through every section of the axon, and it is much slower than propagation in a myelinated axon. The electrical signal reaches the dendrites and then travels to the soma body and then to the axon hillock to initiate the action potential. Then, the action potential must move down the axon by going through each section of the axon, and finally reaching the axon terminal and opening the calcium 2+ channels. This attract and move the neurotransmitters to create a signal or response in the body.
Yeehaw!